Hello, welcome back to the channel. So let's continue our discussion on geometric series, and in this video let's find a formula for the sum of an infinite geometric series. So in the last videos we covered the formula for a finite geometric series when we had finite terms, and we calculated this formula to be a times 1 minus r to the power n plus 1 upon 1 minus r in this case, right? For all values of r not equal to 1, right? So we already derived this formula in the last video and also did one question which was based on this formula. So if you have not watched my previous video, I'll highly suggest you to first watch my previous video in order to get the full idea about how we will use this formula to calculate S infinity, which is the sum of an infinite geometric series. So now we know that the formula for a finite geometric series is represented by Sn, which is this expression over here. So in order to calculate the sum of an infinite geometric series, what we can do is, if we want to calculate S infinity, we can simply take the limit of capital N approaches to infinity in this case, right? So if we, S infinity is basically limit capital N approaches to infinity for S of n, right? If we do that, we'll get an expression for our infinite geometric series, right? I hope that makes sense. Feel free to comment down if you have any doubts in this part over here. So now this is basically S infinity is then basically limit capital N approaches to infinity a times 1 minus r to the power n plus 1 upon 1 minus r in this case. So now if we take the limit n approaches to infinity for this expression over here, we'll get the answer for S infinity. And you can clearly notice that since we are taking limit of capital N approaches to infinity, we are only concerned with this term over here because this term only has capital N. The rest of the terms are independent of capital N. So that is why we are only concerned with r to the power n plus 1 in this case. And now if you observe this expression carefully, you'll notice that when your absolute value of r is less than 1, which means that when your r is in between 1 and minus 1, for example, let's consider your r to be 1 by 2 in this case. So if our r is 1 by 2, this expression will be 1 by 2 to the power capital N plus 1, right? This expression will be 1 by 2 to the power capital N plus 1, and you know that you're taking limit n approaches to infinity, and if we take the limit n approaches to infinity for this expression approaches 0 in this case, right? So, and similarly if you take r equals minus 1 by 2, you can see the same thing over here. So that is why we notice that if our common ratio is, if the absolute value of a common ratio is less than 1, our formula gets simplified to, so S infinity gets simplified to simply a times 1 minus 0 upon 1 minus r in this case, right? Because limit n approaches to infinity, when your absolute value of r is less than 1, this term approaches 0. So your S infinity then becomes equal to a upon 1 minus r, but only for when your absolute value of r is less than 1. And now the next question is, what happens when our absolute value of r is greater than 1 or greater than equal to 1? So what happens when our absolute value of r is greater than equal to 1, which means what happens if your r is either greater than equal to 1 or your r is either less than equal to minus 1. So now you notice that if your absolute value of r is greater than equal to 1, for example, let's consider r to be 3 in this case. So now you're calculating, basically in this expression, you're calculating 3 to the power n plus 1, right? This expression, this term will be 3 to the power n plus 1. And now you know that if you take limit n approaches to infinity for this expression goes to infinity, right? So that is why if your common ratio, if the absolute value of common ratio is greater than 1, S infinity diverges. S infinity does not exist. And you can note the same thing when you take r equals minus 3. If you take r equals minus 3 and limit n approaches to infinity for this expression also diverges, right? So that is why your S infinity does not exist or diverges when your absolute value of r is greater than equal to 1 in this case. So that's all about sum of infinite geometric series. Whenever you're calculating the sum of an infinite geometric series, you have to first notice the absolute value of r, And if you notice that in your infinite geometric series, if your absolute value of r is less than 1, you can totally use this formula. And this also gives us an important observation that whenever our absolute value of r is less than 1 for an infinite geometric series, our series will always converge because the sum is a finite answer over here, right? This will give you a finite value of your sum. So that is why whenever your absolute value of common ratio is less than 1, your series converge. But if your absolute value of r is greater than or equal to 1, your series will diverge. Don't worry, we'll do a couple of problems on geometric series in order to get a good idea about how we can use the formula for an infinite geometric series sum. So that's it for this video. Feel free to comment down on this video if you have any doubts. Follow the channel in order to get notified about the other videos that I'll be uploading. Stay tuned. Thank you so much for watching. Bye bye. Take care.